All right, so this is the natural log exploration, and I don't know why these keep doing this, but I'm guessing this is what your PDF came out as. These were supposed to be giant parentheses, and they're like weird letters. So that's the formula. We know that's the formula for something that's compounded. So we're doing side one. It says side one. We're going to talk about the natural growth exploration here. And so to do that, we're going to need our calculator. You're going to need your calculator kind of right beside you there so you can answer the questions. But it says, suppose that you took $500 in the bank at 6% for 1 year. Find the balance after 1 year. So I want to go ahead and I would like you to pause and I would like you to do this. If you need to watch me do the first one, that's fine. But if it's annually, then I'm just taking this thing and I'm saying, okay, 500 times 1.06. I'm just doing it one time for 1 year. So I'm just going to do 500 times 1.06 and I get 530. So semi-annually would be twice a year. So you're going to do 500 times 1 plus 0.06 divided by 2 to the 2 times 1. And that's semi-annually. So I'm doing 500 times 1 plus 0.06 divided by 2 to the 2. And I got $530.45. So I would like you to take a minute and I would like you to fill in this table. Okay, so I'm just going to put the answers. I would like you to pause. I would like you to fill it in and see if you can answer the questions down below. And then we'll kind of discuss what we're seeing. Okay, so go ahead and do that right now. Pause and do this. Okay, so quarterly is 530.68. Monthly is 530.84. Daily is 530 times 92. Oops, sorry, I just hit the wrong button. And so then if I do hourly, I would times that by, why my calculator does not want to play nice with me tonight is beyond me. And so this comes out as 530.92. The first one was 916. That one was 918. And so then I'm going to get minutely, and that's 530.92. And so then I'm guessing secondly, I can do that, but it's going to be 530.92. So, and this is what's kind of happened sort of in the real world out there. Like, banks will try to kind of, well, they can't anymore with the laws that they've made, but they would try to trip you up with saying, well, I'm going to do 4%, but I'm only going to do it daily. And so this is trying to show you that the number of times compounding, if it's the same account, isn't going to make a difference the more you compound. So describe what happens to the account balance as the number of compounding per year increases. It basically levels off. We've talked about this. It's basically approaching a limit. Okay, it's got kind of an asymptote like the exponentials. How does increasing the number of compoundings per year affect the total amount learned or earned? Well, earned. I mean, it really doesn't. The more it levels off, it stays about the same. Okay, and then finally the last one says, as the number of compounding increases, do you think it approaches the limit? Yeah, this one approaches $530.92. Okay, so there's got to be a way, because secondly, if we think about what the secondly is, to try to figure out that limit, so 365 times 24 times 60 times 60. So there were, 31,536,000 seconds in a year. Okay, and so that's a really big number that you're trying to put into the equation. So there's got to be a better way. So what we're going to do right now is we're going to do the same thing, except we're going to take out all of the things that are causing it to change a little bit. So we're going to do the exact same problem, but instead of putting in $500, we're going to put in $1 to try to take out anything that would change, because timesing by 1 is going to not change anything. And if we make our interest rate 100%, that would be a 1. So if I do this, right, if I say, okay, 1 times 1 plus 1 for 1 year, isn't that going to just be 2? And then if I do 1 times 1 plus 1 divided by 2 for 1 year times 2, because I'm doing it semi-annually, so I'm going to type this in there. So I'd have 1 plus 1 divided by 2 to the 2. I get 2.25, okay? So I want you to do that same thing. So you're going to do quarterly to the 4th and to the 12th and so on, okay? And see what happens. So if I change this, the quarterly one, I would change it to a 4th. And I'm going to divide by 4. And so my answer was 2.44. And if I change it to monthly, then those would change to 12s. And so that's 2.61. And if I do daily, then that would be 365. And I get 2.71457. And so then if I do hourly, I get 2.718. Just going to write that. I know it's money, but okay. And if I do minutely, I get 2.718. Okay, and secondly, change all those. I get 2.718. And so what does it look like it's approaching? It looks like it's approaching the number 2.71828, blah, 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 blah. So then it says take out your calculator. On your calculator, there's a button that says E. It wants you to do, on your calculator, it wants you to do E to the first. And tell me what you get. You get 2.71828. So then they want you to do E 500 times E to the 0.06, because wasn't that what we did in the first equation? And I get $530.92. Isn't that what I got up here? $530.92. So what they found is that E represents continuous growth. So it is that number, continuous growth, or decay, or whatever you're working with. Okay, it is the limit that a compounded function will approach. So instead of having a base, which is this crazy, crazy decimal, you can just turn it into an E. This is what they like to call the natural, it's your natural growth. It is your natural log, and it is whenever they're going to ask the question continuous, you're going to actually convert it into the E.